because we have seen the Laplace transform of a function f of t is given by the integral from 0 to infinity of f of t exponential negative std dt. And that is giving you f of s, isn't it? So it means when there is f of t, we put the function f of t, isn't it? Are we together? Are we together? Yes. So we have the Laplace transform. Our f of t is exponential at. So the Laplace transform of exponential at will be the integral from 0 to infinity. Where there is ft, you put the value of ft, which is exponential at, isn't it? Exponential at, then it is times exponential negative std dt. Then at that point, you apply the laws of indices, isn't it? The laws of indices, same base, you add the power, same base with multiplication sign, isn't it? So then we have the integral from 0 to infinity, same base is exponential, then we add at plus negative st. You get at minus std dt, because you applied the laws of indices, isn't it? When you have same base with multiplication sign, you add the powers, isn't it? Are we together? But now we want it because we are differentiating with respect to t, isn't it? So when we are differentiating with respect to meaning we factorize t outside, isn't it? So it is going to be what? By definition. Can you try to use by definition? So by definition you can see there's a negative here, isn't it? So it means if we factorize negative outside, so we have the integral from 0 to infinity exponential negative. If you remove negative here, you remain with the negative a. What will you remain with? Negative a. Go on. Plus? Okay, let me make it look simpler for you. Let me say just when you factorize t outside, you remain with a minus s, isn't it? So when I want s to start, it means I now factorize out the negative, isn't it? So when I factorize out the negative, it will now be s minus into t. So you can see negative times s, you get back to a negative, isn't it? Then negative into positive, you get back to a positive. Because I want s to start by definition, isn't it? Are we together? Yes. You've seen the criteria, isn't it? So by definition, if you can see this by definition, this is a case of a shift theorem. You can see the position where s is occupied by definition. What is now occupying that position? S minus a, isn't it? Meaning this is supposed to give you f of, it is supposed to give you f of s minus a. Because if you have s, because in this bracket here we have s, negative and t is outside. Inside this bracket we have s. Then we are getting the f of x, isn't it? Meaning inside this bracket when we have s minus a, meaning we're supposed to get f of s minus, isn't it? You're supposed to get f of s minus a to be the answer, isn't it? Are we together? Yes. So that is the Laplace transform of that. So it is f of s minus a. But now, how do we get it, isn't it? That is an exponential function, isn't it? You check on the derivative, isn't it? So the derivative will be what? Remember, even from here, you can have here your f, it is f of s minus a. Look the way the answer was going to look. If Laplace transform of a was a over s, isn't it? So it means in this case, you are looking for the Laplace transform of 1, because f of t is like 1 exponential that, isn't it? So it is going to be 1 over s, but now instead of s, we have s minus a, isn't it? So it means the answer then should have been 1 over s minus. So we want to see how that is coming about, isn't it? Are we together? Yes. Good. So how is that coming about? When you are integrating an exponential function, the derivative of the inner function must be a constant, is when you integrate it, isn't it? So here, t is the variable, meaning the constant is negative s minus a, isn't. So if you differentiate t, you get 1, so you just remain with the constant negative s minus, isn't. So if you integrate an exponential function, it remains the way it is, then you divide by the derivative of the inner function, which is negative into s minus, isn't it? Because negative into s minus, the whole of it is a constant, t is the variable, isn't it? See, if you differentiate, meaning you just take that constant back and you divide it with, because that derivative is a constant, isn't it? Are we together? Yes. Now, are we together? Good. Then you put there the limits of integration is from 0 to infinity, isn't it? So what do? You factorize outside there the constants, isn't it? Remember when you are integrating if you have something like exponential 2t, you want to integrate exponential 2t, the derivative of this 2t must be a constant. So if you differentiate 2t, you get 2, isn't it? So it remains exponential 2t, then you divide by that derivative, which is 2, which is exactly what we've done here. The constant a is negative s minus a. If you differentiate t, you get 1, isn't it? So it means you take the way it is and you divide by that constant. Are you seeing that? Good. Now from there, what do we have? Take out the constant term. Take out the constant term. The constant term is negative 1 over, because negative can be written anywhere. So negative is outside. So this one means it is 1 over that. So it is negative 1 over s minus a. Then inside the bracket, you substitute. When you put infinity where t is, what did we say? Exponential, it is now going to be exponential negative infinity, because infinity is now a very big number, isn't it? So exponential negative infinity you found to be 0. When you just put in a very big number there, isn't it? Then it is minus, where there is, if you substitute 0, remember this we've already factorized outside, meaning this is what is left inside, isn't it? When you put 0 there, everything goes to 0. So exponential raised to power 0 is 1. So in the end, what do you get to be the answer? 0 minus 1 is negative 1, isn't it? So negative 1 times negative 1 it becomes positive. Yes. So you remain with 1 over s minus a. Are we together? Are we together? Yes. So that is the second predefined formula. We've seen the first predefined formula in case if f of t is a constant, isn't it? Then next we've seen in case if f of t is exponential at. So